We're going to be working through a BCA stoichiometry problem where you start off with grams and are going to be asked to convert how much products and excess reactant you have in grams. So as always, we start with the chemical equation. So I start by underlining what my reactants and my products are, and I ignore these numbers. So I have NH3 plus Na, and my products are NaNH2 plus H2. So if I were to balance this out, I would have 2, 2, and 2 over here. That means I have, for every 2 moles of NH3, I need 2 moles of Na to produce 2 moles of NaNH2 and H2. So my next step is placing these balanced chemical formulas into my BCA table. And I use one column for each reactant and product. Now, because these are in grams, and this recipe or this chemical equation is in moles, I need to convert my grams into moles. So I start off by using gram to mole conversion. If I have 50 grams of NH3, I look at my periodic table and I see that 1 mole of NH3, N being 14.01 grams, and each hydrogen being 1.01 gram. If I add those those chemicals together, it works out to be 17.04 grams of NH3 over 1 mole of NH3. And this calculates out to being 2.93 moles of NH3. Like I said, my chemical equation is in the language of moles, so I need to make sure that I convert those grams. So instead of writing 50 grams here, I write 2.93 moles of NH3. For sodium, I do the same thing. I'm given 30 grams of sodium. I need to use dimensional analysis to actually convert those grams into moles. I look at my periodic table and I see that it takes, 1 mole of sodium is 23 grams. I write my equivalency fraction. These cancel out, and I should show you that on this side too. This shows us that we've done it correctly, and this value works out to be 1.3 moles of Na. So that's the value that I have over here. I haven't combined my reactants yet, so I don't have any product, so I place a 0 here. Now, I look at my equation and it tells me that for every 2 moles of NH3 I need to have 2 moles of Na. So these numbers should actually be a 1-to-1 ratio. And when I look at them, I see that they actually aren't. And while this is super easy to do in your head on how to get the value of each of these, when you're working through these, I want you to use dimensional analysis. So to start off with, I know that they should have a 1-to-1 ratio. Which one is it that I have too little of? And that is Na. Because for a 1-to-1 ratio for NH3, I need to have, for every 2.93 NH3, I need to have 2.93 NAs, and I clearly don't. So this will run out, and I place a minus 1.03 moles on that, and I'm left with nothing. Okay, this is my limiting reactant. In that case, when I use dimensional analysis, I always use my limiting reactant because I can only make as much as the least ingredient I have. So I take that 1.3 moles of Na, and I look at the relationship between Na and NH3, and it tells me that for every 2 moles of Na, it requires 2 moles of NH3. That's thanks to my chemical equation. So in that case, when I write my equivalency fraction, I want to make sure that I can convert or cancel out this Na and transform or convert it to NH3. So in this case, 2 moles of Na would be on the bottom, so I can cancel these out with 2 moles of NH3. They cancel out, and 1.3 times 2 is 2.6 divided by 2 is 1.3. We're going to place a minus sign here to show that we're using up 1.3 moles of NH3. How much do we have left over? Well, of the 2.93 moles we have, we use 1.3 moles. That means we are left with 1.63 moles of NH3 left over. So we were able to accomplish a couple of things. First of all, we figured out what our limiting reactant was. That's this one, so I circled it. I figured out what my excess reactant was. That's this one over here. And I realized that I had 1.63 moles of excess reactant. So next comes figuring out how much product we have. Now you notice this is a 2-to-2 relationship, which is the same as a 1-to-1 ratio. So naturally, if I have 1.3 used, then 1.3 will be made. While I love that you can do it in your head and should do it in your head, I want you to also be able to do it as a chemist. So again, you take your limited reactant, and I have 1.3 moles of Na, and I set up an equivalency fraction. I know that for every 2 moles of Na, I need 2 moles, or it produces 2 moles of NaNH2. I set that up so that I can cancel out my moles of Na, so that means the 2 moles of Na are on as a denominator, and 2 moles of NaNH2 are in the numerator, so these cancel out. 1.3 times 2 is 2.6 divided by 2 is 1.3. I have now 1.3 moles of NaNH2. So I write that down as my final product. For this one here, again, I notice that I have a 2-to-1 ratio. In other words, for every 2 NAs that are made, we have half the amount of H2. So in this case, again, I'm going to set up my dimensional analysis. I have for 1.3 moles of Na, my relationship, as I mentioned, was 2 moles of Na is equivalent, will produce 1 mole of H2. And with this one here, to cancel out my Na, I place 2 moles of Na on the bottom and 1 mole of H2 on top. This works out to be 0.65 moles of H2 that are produced. In other words, we place that right in our after section over here. Okay, so well on our way to finishing off this equation. It does ask me how many grams of excess there are. How many grams of each product there are. Well, I know that I have 1.3 moles of NaNH2, but I need to convert that into grams. So again, I use my periodic table, and my periodic table tells me that every 1 mole of NaNH2 has a mass of 39.03 grams of NaNH2. These cancel out, and with my calculations, my answer works out to be 50.9 grams of NaNH2. So that's one of my answers. It also asked me to see how many grams of H2 I have. So I know I have 0.65 moles of H2. I look at my periodic table and I know for every 1 mole of H2, it's 1.01 grams of H2. These cancel out, and if I do my calculations, it works out that I have 66 grams of H2. All right, so that gives us both of those answers. I do also want to know how much excess I have. So I see over here that I have 1.63 moles of NH3 left over. And in this case, I know that 1 mole of NH3 weighs 17.4 grams. These cancel out, and my answer works out to be 27.7 grams of NH3. So that allows me to figure out the grams of each one. Notice that the only time I'm using these coefficients is only in this stage right here. I don't use them for converting grams into moles or moles into grams. So do not use those coefficients for anything else other than the change.